Welcome to my presentation about the chemistry of pyrotechnics. Firstly, what exactly are pyrotechnics? Pyrotechnics is defined as the science of using exothermic chemical reactions for the production of heat, light and sound, which basically covers all explosions, fires, that sort of thing that you'll see in movies and television shows. Here's a clip from the recent James Bond film Spectre. In 2015, this particular explosion made it into the Guinness World Book of Records for the largest stunt explosion in cinematic history. But how exactly do they do it? I'm going to mainly look at dynamite and gunpowder, as these are the most commonly used explosives for pyrotechnics. This is because they both have high brisance. Now, brisance can be defined as the shattering effect of an explosive, which means that there's a greater pressure at detonation, so we see a large explosion. I'm going to begin by looking at dynamite. Dynamite is primarily nitroglycerin, about 75%, which you can see the structure of on the screen now, but it also contains diatomaceous earth. Diatomaceous earth is a sedimentary rock, and interestingly, it prevents nitroglycerin from decomposing until heat is applied. Once heat is applied, the nitroglycerin decomposes and creates high pressure detonation, which leads to the explosion that we see. Here is the equation for the decomposition of nitroglycerin once heat is applied. Notice that nitroglycerin is a liquid at room temperature, but all the products are gases. The fact that the volume expands so rapidly causes the explosion that we see, hence the high brisance, which is what makes dynamite so well suited to the high impact explosions that we like to see on the big screen. I'm going to move on to talking about gunpowder now. Old-fashioned gunpowder tends to be used more often than modern gunpowder in special effects. This is because it produces more smoke and therefore adds to the effect and is easy to pick up on camera. Gunpowder is made up of saltpeter, which is potassium nitrate, charcoal and sulphur. Here's a more detailed look at what makes up gunpowder. Gunpowder is 75% saltpeter. Saltpeter is used because it decomposes at high temperatures, and this provides oxygen for the reaction. This means that gunpowder does not necessarily need air in order to burn. A further 15% of the composition of gunpowder is made up of charcoal. The main purpose of charcoal is just to provide carbon that acts as a fuel for the reaction. The final 10% is sulphur. Sulphur can also act as a fuel, but its main purpose in gunpowder is to lower the ignition temperature of the charcoal. This works because sulphur can undergo an exothermic reaction at relatively low temperatures, which provides more energy in the reaction and makes it easier for the activation energy to be overcome. Once the gunpowder is ignited, rather than one simple single reaction taking place, there are many different complex reactions, which made it difficult to determine the precise reactions for the combustion of gunpowder. Instead, we use this simplified equation. This gives us an idea of the products that we get from our reactants. The products are a mixture of solids and gases, with the gases, in the carbon dioxide and the nitrogen, acting as propellants, pushing the cloud of smoke up into the air, which creates the high impact that is required for the big screen. Thanks for watching, and I hope you enjoyed it, even if it's just the tiniest bit.